Okay, here's my first homework video I've ever created. So we're going to review the unit circle. Here's your key for your homework. I'm going to zoom in a little bit. That way we can see each problem. So the goal for you guys is to be able to do this process that I'm about to do to figure out the cosine of 3 pi over 4 in your head. Okay? And I find that it's helpful to, and I talked about this in the lesson, recall SOHCAHTOA, and remember triangles, not remember coordinates. So 3 pi over 4. First thing I'm going to do is find the location of an angle. Well, I know pi is here. I know going clockwise would be subtracting an angle. Going counterclockwise would be adding. So if I start at pi, knowing that that's the same as 4 pi over 4, I could subtract the pi over 4, and I'd be in the third quadrant. This would be the location of 3 pi over 4. Okay, and then I go ahead and understand that this is a circle that's going around. So this is why I stopped my angle, because I have a circle. This hypotenuse is 1 for this right triangle that I'm creating, which is our 45, 45, 90 triangle. Why is it 45 degrees? The reference angle to the x-axis, because we have a pi over 4, and all pi over 4s would be a 45 degrees. So in my special 45, 45, 90 triangle, I have side lengths of root 2 over 2. I consider this negative because I'm going to the left on the x-axis. This is positive because I'm going up. So cosine in the SOHCAHTOA, the ka is adjacent over hypotenuse. Adjacent would be the horizontal if we're always talking about a reference angle between our angle and the x-axis. Adjacent is always the horizontal distance. The horizontal distance of my triangle that I create is this negative root 2 over 2. Okay, and that's my thought process in my head. Find the angle, create the triangle, cosine, adjacent, always going to be horizontal. Here's sine, 5 pi over 3. I know where 6 pi over 3 is. It's here at 2 pi. So I'm thinking, okay, this is 2 pi. That's the same as 6 pi over 3. Again, I'm going to subtract. Again, if we go counterclockwise, that'll be adding. If we go clockwise, that'll be subtracting. So take a pi over 3 away, and that puts me in this fourth quadrant at 5 pi over 3. A pi over 3 is a 60-degree reference angle. So I'm creating this tall 30, 60, 90 triangle, where in a 30, 60, 90 triangle, I have a shorter side and a longer side. Well, if it's a tall 30, 60, 90 triangle, the shorter side, the 1/2, is going to be the adjacent side, or the horizontal side. The longer side is the vertical side. That's the root 3 over 2. However, since I'm going down on the y-axis, this would be a negative root 3 over 2. This 1/2 is a positive. Sine in the SOHCAHTOA, sine is opposite. It's always going to be the vertical. So cosine is always the horizontal, sine is always the vertical. So sine being the vertical, opposite root 3 over 2, negative. Okay, that's the vertical side length. That's opposite. Remember, the hypotenuse is always 1. So opposite over hypotenuse, if you want to think of so. But whenever we're doing this, understand hypotenuse is always 1. Okay, tangent 3 pi over 4. I already did a 3 pi over 4 over here. Tangent is sine over cosine, or opposite over adjacent, or vertical divided by horizontal. Vertical divided by horizontal. For tangent for a pi over 4, it's going to be root 2 over 2 over negative root 2 over 2. That's going to be just 1, but negative 1 since it's a positive divided by a negative. Sine of 4 pi over 3. Let's find 4 pi over 3. Here's 3 pi over 3. It's the same as pi. Add now. Adding is going counterclockwise. So starting at 3 pi over 3, adding, going to 4 pi over 3 would be here. I create my 30, 60, 90 triangle, knowing that it is the taller 30, 60, 90 triangle. The adjacent side would be shorter. The longer side, the root 3 over 2. Both would be negative since I'm going left and down. Sine of 4 pi over 3, opposite side, vertical distance, negative root 3 over 2. Cosecant, first thing we got to remember is that cosecant is the reciprocal of sine. So I'm going to find the sine of 7 pi over 4 and then just flip it We'll put it under 1. I got to find 7 pi over 4. I know where 8 pi over 4 is. 8 pi over 4 is right here. Subtract a pi over 4. Again, adding, subtracting. So going around clockwise is subtracting. Puts me in the 4th quadrant. We have a triangle with side lengths of root 2 over 2, since it's the 45, 45, 90 triangle. And we would have a negative vertical distance, since I'm going down with my triangle on the xy axis. Sine opposite over hypotenuse. The vertical side length is negative root 2 over 2. So I'd have 1 over negative root 2 over 2. This is the same as 2 over negative root 2. In this class, it is not a requirement to rationalize. You can leave your answer as negative 2 over root 2. So sometimes on multiple choice problems, you'll see this being simplified. We'll talk more about simplification throughout the course of the year, but the easy way to talk about simplification is for AP Calculus. Simplification is not required for free response. However, it might be required to see the correct answer on a multiple choice problem. So you're not required to simplify this if this was just a regular problem on like a quiz, but you may be forced to know how to rationalize this in case you don't see this answer on a multiple choice problem, and you need to realize that this is the same as 2 root 2 over 2, which is the same as negative root 2. Okay, E2's will cancel, we have just multiplication. Cotangent pi over 4, this is easy. Tangent and cotangent are reciprocal, so if I just find the tangent of pi over 4, just flip it or take it 1 over that fraction, pi over 4. Cotangent you can even consider as being the adjacent over opposite instead of opposite over adjacent. Pi over 4, we have our 45, 45, 90 triangle. So adjacent over opposite is going to give us 1, or opposite over adjacent will give us 1. This will be 1 over 1. This is good. All right, pi over 6. Finally, we have a pi over 6, which creates a 30-degree reference angle with the x-axis. Here's 0. Add a pi over 6. We will be going counterclockwise. This creates our shorter 30, 60, 90 triangle. And in our shorter 30, 60, 90 triangle, the vertical side is the shorter distance. The horizontal side is the longer distance. Cosine being adjacent or the horizontal distance is root 3 over 2. Now, I could be doing this on my head. I'm kind of showing you the thought process I have in my head so that hopefully you can do the same, so that we don't have to be spending so much time on these. Like, I can easily go sine of pi over 2 is 1, or the cosine of pi over 6 is root 3 over 2, after just thinking about it for a little bit. But I'm showing you this stuff is my mental process. Why is the sine of pi over 2 1? So this is when we start talking about the extremes. So when we're on the x-axis or on the y-axis. Pi over 2 is halfway from 0 to pi. So halfway from 0 to pi would be right here. It's a 90-degree angle. And why is sine 1? Well, again, sine is always the vertical distance. Okay? I know you're thinking opposite over hypotenuse, but like, we don't have a triangle here. I just have a straight line. But it's okay. We can consider us having a triangle with the adjacent side or the horizontal distance being 0, whereas the vertical side, which is the opposite side, which is the vertical distance, being 1. The hypotenuse stays 1, so we don't really have to worry about it. Just sine, opposite, vertical distance, I'm going up 1 to get to this location on my unit circle. Pretend like we have a unit circle there. And I will travel up 1 to get to pi over 2. I will not go to the right or to the left at all if you consider starting at the origin. Okay, the horizontal distance is 0, the vertical distance is 1. That's why the sine of pi over 2 is 1. That's why the cosine of 0, if I ask you what is the cosine of 0, Well, here is the location of the angle measurement 0. I will travel to the right 1, but I will not go up or down at all. So since I don't go up or down at all, but I do travel to the right 1, the cosine of 0 is 1. All right, 3 pi over 2. Another extreme, 3 pi over 2 is down here. Tangent, opposite over adjacent, vertical divided by horizontal. Vertical distance, I'm going down 1. Horizontal distance, I'm not traveling to the left or to the right at all. So vertical, horizontal, that would be tangent, opposite over adjacent. Negative 1 over 0, that is undefined. You are not allowed to divide by 0. So there is no tangent of 3 pi over 2. It does not exist. Cosecant of pi over 3. Cosecant is the reciprocal of sine. So we'll start with the sine of pi over 3. And we will flip it or put it underneath 1. So pi over 3 creates our 60-degree reference angle. It'll be in the first quadrant. It's our tall 30, 60, 90 triangle, which means this is our longer side, the vertical side. This is our shorter side, the horizontal side. Sine of pi over 3, root 3 over 2. That is placed under 1, sine being the opposite or the vertical side distance. So that's placed under 1. So what do I do here? I can either 1 divided by root 3 over 2, that's the same as 1 times 2 over root 3. Remember, when you're dividing fractions, it's the same as multiplying by the reciprocal. We can multiply straight across to get 2 over root 3. This is fine. You may leave your answer like this on a quiz. However, you need to be prepared to rationalize for like a multiple choice problem if you don't see this answer on a test. So for a quiz, this is fine to leave it 2 over root 3, but be prepared to simplify and rationalize. I don't want to call this simplifying. I don't think this is simpler than this. This is just a different way to look at 2 over root 3. So don't call it simplify, call it rationalize. All right, popping over to 11. Sine of 7 pi over 6. Okay, I know where 6 pi over 6 is. It's the same as pi. So here's pi, here's 6 pi over 6. So I'm thinking about that first. 6 pi over 6 is just another way to write pi. If I add a pi over 6, that puts me in the third quadrant. Pi over 6 gives me a reference angle of 30 degrees. That's a short 30, 60, 90 triangle. So here's pi, 6 pi over 6. Add a pi over 6 puts me there. Remember, adding, subtracting. Sine is our vertical distance. For our shorter 30, 60, 90, the vertical distance is going to be the shorter side length. The horizontal distance will be the longer side length. I'm going down, so my vertical side distance is negative. I'm going to the left. My horizontal side distance is negative. So sine of 7 pi over 6 being the opposite, or the vertical, is negative a half. Secant, reciprocal of cosine. Let's find the cosine of pi over 6. Pi over 6, again, 30-degree reference angle, short 30, 60, 90 triangle. Short 30, 60, 90 triangle. Vertical is the shorter side. Horizontal is the longer. Cosine being the horizontal or the adjacent. That's the longer side. Cosine adjacent over hypotenuse. Adjacent over hypotenuse. Horizontal side length divided by 1, or just the horizontal side length. We can write it like this. This is fine. We can write it like this. This is good. We can rationalize as well, which we just did in the previous problem. Secant, reciprocal of cosine. Let's find the cosine of 7 pi over 4. We have to locate 7 pi over 4. Where is 7 pi over 4? Well, I know where 8 pi over 4 is. It's over here at 2 pi. Remember, this is 0. This is pi. Keep going around. This would be 2 pi. Well, I can write 2 pi as 8 pi over 4. I can write it as 6 pi over 3. I can write it as 12 pi over 6. This is how we find those angles. 7 pi over 4 would place me right here, 1 pi over 4 less than 8 pi over 4. So subtract the pi over 4, go in a clockwise manner. Creating our 45, 45, 90 triangle. side lengths root 2 over 2 and root 2 over 2. This would be negative because I'm going down. This is positive. The cosine would be our adjacent side length, our horizontal side length, our positive root 2 over 2, which goes in the denominator. So I have 1 over root 2 over 2, which is the same as 2 over root 2. Which is the same as 2 root 2 over 2, which is the same as root 2. And a reminder, you can multiply the top and bottom by root 2 to get this. All right, I'm just going to breeze through the rest of them. I feel like I've shown enough examples. Maybe I'll do the cosine of pi, but here's what I'm doing. In my head, sine of 2 pi over 3. Okay, 3 pi over 3, subtract the pi over 3. That's going to be put me right here. 2 pi over 3 is our taller. Sine would be our vertical side length. Vertical side length, since I'm going up, is the longer side of my 30, 60, 90 root 3 over 2. Tangent of 5 pi over 6. Okay, 5 pi over 6 is going to be right here, because this is 6 pi over 6. Subtract the pi over 6, I put 5 pi over 6. Tangent is opposite over adjacent, vertical over horizontal. The vertical is the smaller side length. The horizontal would be the longer side length. I am going up and to the left to get here. So I have 1/2 divided by negative root 3 over 2. You can leave it like that, but you probably need to understand how to simplify it. Fractions multiplied by the reciprocal of the denominator. Boom, you have 2 over 2 root 3 being negative. The 2's cancel. I have 1 over negative root 3. That's fine. You can leave it like that. But we need to know how to rationalize, multiply the top and bottom by root 3, and you get negative root 3 over 3. Sine of pi over 3. Pi over 3 right here. So 60 degree, taller 30, 60, 90. Sine, the longer side, is the vertical side. So sine opposite, that's the longer side. That's the root 3 over 2. Secant of 5 pi over 3. Well, secant's a reciprocal of cosine, so let's find the cosine of 5 pi over 3. 5 pi over 3 down here. This is 6 pi over 3, take 1 away. Cosine would be the shorter side length. Cosine is going to be 1/2. So I'll have 1 over 1/2, because this is the cosine of 5 pi over 3. So I have 1 over 1/2. I'm going to the right. And then down, if it was the sine, it would be negative root 3 over 2. But anyways, the reciprocal of 1/2 is just 2, or 1 over 1/2 is just 2. Cosine of pi, pi is over here. If you think about on a unit circle, to get over here, we have a horizontal distance of -1, since I'm going to the left. I do not have any vertical distance. I'm not going up or down. Cosine being the adjacent or the horizontal distance. The horizontal distance to get over there is -1. Cotangent, adjacent over hypotenuse, or horizontal divided by vertical. 2 pi is the same location as 0. So horizontal distance would be 1. Vertical distance is 0. I'm not going up or down at all, starting from the origin, getting to this location on my unit circle. So horizontal 1, vertical 0, undefined. All right, tangent is opposite over adjacent. So that would be vertical over horizontal, cotangent, flip it. Secant, reciprocal of cosine. Cosine of pi. We already did. It's -1. 1 over -1. -1. Sweet. All right, so hopefully we breezed through that. If we are good, if we are not strong at this, this needs to all be able to be done by memory without referencing any other charts or manipulatives we created. We need to be able to create these triangles and use our brain. Let's go to the back page. We're solving equations now. So we're using our unit circle knowledge to be able to figure out what x values work in this equation. We want all solutions to be between 0 and 2 pi. So keep that in mind. Usually there will be a stipulation about your domain where your solutions can be in, because there's an infinite amount of solutions for all these equations. So we don't want to worry about that. We don't have to worry about the notation for an infinite amount of solutions, like, oh, add 2 pi to this, or oh, add pi to this. We are just going to find solutions in a specific domain in this class. So that's good if you had questions about that. So sine of x is 1. I figured that out by isolating the trig function. Sine of x, I subtracted 2 from both sides. Sine of x is equal to 1. Now I use my unit circle knowledge, sine being the opposite or the vertical. When is the vertical distance equal to 1? Right here, the vertical distance is 1. Right there is pi over 2. And that's my only solution between 0 and 2 pi. Now, if I did not have that stipulation between 0 and 2 pi, you would go to pi over 2, and then you'd keep going around. You could also say that this is at negative 3 pi over 2. Why negative? If I started at 0, went clockwise, this would be negative 3 pi over 2. Same location, same sine value, but a different angle measurement. We could go to pi over 2 and go all the way around the circle. 2 pi is 4 pi over 2. Add a pi over 2, this would be 5 pi over 2. You can keep going, 6, 7, 8, 9 pi over 2. So you have an infinite amount of angles that would satisfy this equation. However, we are only going to concern ourselves with the one between 0 and 2 pi. Number 2, tangent of x times root 3 plus 1 is 0. So I get tan x by subtracting 1. I'll have root 3 tan x is equal to negative 1. I'm going to isolate the trig function first. Get tan x is equal to negative 1 over root 3. I'm going to probably rationalize this to give me negative root 3 over 3. And now with tangent, these are tricky. Like, all right, I know that at pi over 4, tangent is always 1 or negative 1. But root 3 over 3, which one is it? Well, we really should come down to 2 possible situations. I have my tall 30, 60, 90 triangle or my short. Now, I don't have this memorized myself. I kind of have to figure it out, and I can do it in my head. Well, I have a situation where I have an opposite over adjacent, which is root 3 over 2 divided by 1/2, or an opposite over adjacent, which is 1/2 divided by root 3 over 2. If I take this divided by this, it'll just get root 3. So the tangent of this angle would just be root 3. The tangent of this angle, if I have 1 over 2 divided by root 3 over 2, I would end up canceling the 2's, and you could do this out. You'd have 1/2 divided by root 3 over 2, which is 1 over 2 times 2 over root 3. This would give you a tangent of this angle to be 1 over root 3. Okay? 1 over root 3. Boom, I see it right there. I didn't have to rationalize at all. So I got tangent of an angle is equal to 1 over root 3. So that's going to be at this situation. This situation is at a pi over 6 angle. But we have a negative. So when is tangent negative? Well, I remember tangent in the first quadrant is going to be positive. It'll be negative in the second quadrant because we'll have negative horizontal, positive vertical. It'll be positive in the third quadrant. Both horizontal and vertical are negative. It'll be negative in the fourth quadrant. One easy way to remember what is positive where is this acronym. All students take calculus. This is telling you that all trig functions are positive. This is telling you that sine is the only trig function that is positive in the second quadrant. This is telling you that tangent is the only trig function that is positive in the third quadrant. And cosine is the only trig function that is positive. This is also including their reciprocals. So sine and cosecant are positive. So where is tangent negative? Tangent is negative here. Tangent is negative here. So I'm going to say, all right, I need the pi over 6 location here, the pi over 6 location here. Well, this is 6 pi over 6. Subtract the pi over 6. I get to 5 pi over 6. This would be 2 pi, which is 12 pi over 6. Subtract the pi over 6. I get to 11 pi over 6. This is my easiest way of getting to those angle measurements. This is like the pi over 6 here. I start with 6 pi over 6. Subtract is that way, clockwise. Add is that way, counterclockwise. Here, this will be 12 pi over 6. Subtract that way. Add would be going that way. So that was pretty tricky for number 2. Here we go. Let's isolate secant. I'll subtract 8 divided by 4. Secant x is equal to negative 8 over 4, which is negative 2. So if I think about it, secant being equal to negative 2, that would be the same as like 1 over cosine being equal to negative 2, or cosine being equal to negative 1/2. So solving this equation is the same as solving this equation. So I need to figure out when cosine equals negative 1/2. Well, I know I have a tall 30, 60, 90 triangle. That's when the adjacent side is shorter than the vertical side. That happens at a pi over 3 reference angle. So I need to figure out, okay, when is cosine negative? Cosine is negative here and here. So cosine's negative in the second and third quadrants. So I need the pi over 3s in the second and the third quadrants. So that would be this reference angle right here and this one down here. What is that? Well, this is 3 pi over 3. Subtract 1, this would be 2 pi over 3. Add 1, this will be 4 pi over 3. Next one, another tangent. Cotangent of x equals root 3. So cotangent x equals positive root 3. You could say, okay, that's the same as 1 over tangent of x is equal to root 3, or tangent of x equals 1 over root 3. Cotangent is 1 over tangent. You can flip. Got tangent of x is 1 over root 3. I think we already figured that out. Tangent 1 over root 3 is at this pi over 6 angle. Again, it's you know it's not at a pi over 4, so it's either pi over 6 or pi over 3. I think about this situation at pi over 6, and you can even go straight to cotangent being adjacent over opposite. And if I have root 3 over 2 divided by 1/2, root 3 over 2 divided by 1/2, that gives us root 3. So boom, we got it. It's going to be at this type of triangle. This type of triangle is created with a pi over 6. So I'm thinking pi over 6. Now, which pi over 6 do we have? Again, you can use the ASTC to help you. All students take calculus. Tangent is positive in the third quadrant. Tangent is also positive in the first quadrant. So I want the pi over 6 in the first quadrant, and I want the pi over 6 in the third quadrant. So here is the first quadrant. Here is the third quadrant. This would just be pi over 6. This, I start with 6 pi over 6. I know I'm down, so I'm adding a pi over 6, and that gives me 7 pi over 6. I don't want to say down. I'm going counterclockwise. Counterclockwise is adding. So I'm adding a pi over 6 to get there. That's a 7 pi over 6. Okay, so that's my solutions. X is pi over 6 and 7 pi over 6. All right, let's isolate. I'm going to add 9 root 3 divided by 18. I get cos x is equal to 9 root 3 over 18, which ends up being root 3 over 2. It's a positive because I have to add the 9 root 3 divided by the 18, root 3 over 2. All right, cosine is the adjacent. When do I have an adjacent side length? That's root 3 over 2. That's at my shorter 30, 60, 90 triangles. So this side length is root 3 over 2. Cosine is positive here in the first and the fourth quadrant. This skinnier, shorter 30, 60, 90 triangle is at a pi over 6. So we're dealing with pi over 6 again. But I need the pi over 6 here in the first quadrant, where cosine's positive, and here in the fourth quadrant where cosine's positive. So that is at pi over 6. And let's see, I go all the way around to 2 pi. That's 12 pi over 6. Subtract a pi over 6, I get to 11 pi over 6. Next one, add 4 root 2 divided by 8. I get cos x equals positive 4 root 2 over 8, which is positive root 2 over 2. Cosine, again, is positive in the first and the fourth quadrants. So I'm looking for angles in the first and the fourth. Root 2 over 2, that's going to be my 45, 45, 90 triangle, where the cosine, the adjacent side, is root 2 over 2. So I'm talking about the 45-degree angle here, the 45-degree angle here, which is my pi over 4 here, and my pi over 4 here. How do I find this pi over 4? Well, think about 2 pi. If I go all the way around the circle, I get to 2 pi. That is the same as what pi over 4? 8 pi over 4. 8 pi over 4, subtract a pi over 4, 7 pi over 4. This is easy. When it's sine root 2 over 2, we don't have anything to solve. We just have to find when our vertical side lengths are root 2 over 2 and positive. Sine is positive in the second quadrant and the first. The vertical side length is root 2 over 2 at our pi over 4s. So our pi over 4 here, a pi over 4 here. So my angle is pi over 4. What's this? I know this is pi, which is the same as 4 pi over 4. Subtract a pi over 4, I get to 3 pi over 4. All right, now we get into something that's a little bit trickier. What's really important is that you cannot multiply this 2. This x over 2 is tied into the cosine. We'd have to get rid of cosine first before we get rid of 2. Now we cannot do that. So we need an alternate way to solve this problem. What I'd like you to do is to think about, okay, when is cosine of just an angle equal to root 2 over 2? And we've already kind of done that. It's right here at pi over 4 and 7 pi over 4. We just did that in the previous problem. But this angle is actually x over 2. So x over 2 will equal pi over 4 or 7 pi over 4. Now, let's solve for x. To solve for x, I will multiply everything by 2. And when I get my answer, I get pi over 2 and 14 pi over 4, which is 7 pi over 2. Okay, great. Wait, hold on a second. I told you that your answers needed to be between 0 and 2 pi. Because we took these angles, which started out between 0 and 2 pi, here and here, but then manipulated these angles to solve for x. I multiplied everything by 2 to solve for x. It's no longer an angle pi over 4. X is now this, answer pi over 2. Well, that's between 0 and 2 pi, sure. But 7 divided by 2 is bigger than 2. So 7 pi over 2 is bigger than 2 pi. So 7 pi over 2 is actually an answer that I'm not going to include. Why? Because it's not between 0 and 2 pi. So that's gone. That's why I'm just going to answer pi over 2. I like this one. Multiple ways to do this. You could divide both sides by cosine. And when you divide both sides by cosine, you get when is tangent equal to 1. Well, I know that at the pi over 4s, when I have root 2 over 2 divided by root 2 over 2, that the tangent of this angle is 1. So that's at a pi over 4. When is tangent positive? Tangent is positive in the first and the third quadrants. So I want the pi over 4 in the first quadrant, and I want the pi over 4 in the third quadrant. Remember, this is 4 pi over 4. I'm going to have to add a pi over 4 to get to 5 pi over 4. Another way to think about this is like when are cosine and sine the same? Same process to get to the answer. Look at that. It's the same problem. So we literally just solved this problem. That's nice. Now my question is, what would happen if I put a negative here? Now a lot of people think, oh, this is when cosine's negative and sine is positive, but they get the same. But actually, if you divide by just cosine, if I divide by cosine, I would actually get -1 is equal to tangent. Now -1, when it's tangent -1, tangent is negative in this quadrant and this quadrant, whereas that would be at 3 pi over 4, this is 8 pi over 4, this would be 7 pi over 4. So just be careful, just because you see a negative in front of one thing or another doesn't mean like we're talking about just this angle when cosine's negative or just one angle. You can see it's just when is tangent equal to -1. Be ready for that. All right, now we got some manipulations here. We got sine of 3 theta. Again, you can't get rid of the 3. It stays in the trig function. We just have to figure out when is sine -1. All right, well, sine is -1 at 3 pi over 2. Okay, great. So when we are down here, we are going down 1. That's the vertical side length, 3 pi over 2. It's not something I've memorized. I'm thinking about vertical distance being -1. I'm going down 1. I go to the left or the right, 0. Okay, but that would be like if I had just like y. Y would equal -1. But now I have 3 theta. So the thing is like the sine of 3 theta has to equal 3 pi over 2. Now, I can manipulate this by either dividing by 3 or multiplying by 1/3. Dividing and multiplying by reciprocal are the same. I would prefer, and I like to multiply by the reciprocal. I think it's just a little bit nicer when dealing with fractions. Giving me theta is equal to, okay, 3 pi over 2 times 1/3. It's just pi over 2. Great. This is between 0 and 2 pi. I'm happy. However, notice I take 3 pi over 2, divide by 2, I get a smaller angle. Turns out, I might have another angle that I start with, that when I divide by 3, the new angle, this theta, which has to be between 0 and 2 pi, that might end up still inside my range of 0 to 2 pi. Let me show you what I'm thinking, okay? Let's keep going around the circle. Okay, so 3 pi over 2, this is 4 pi over 2 or 2 pi, 5, 6. This would be 7 pi over 2 as well. It's the same location, but a different angle. Okay, because I've gone around the circle once and then another 3/4 of the way around the circle. Now, if I take 7 pi over 2, and if I multiply that by 1/3, I get 7 pi over 6. This angle is also between 0 and 2 pi. So since that's still between 0 and 2 pi, I need it as a solution. Even though this started out outside 0 to 2 pi, the question is all of my solutions for theta, all my solutions for that need to be between 0 and 2 pi. So this is why we're going to have to look at expanding our original angles outside of the 0 to 2 pi range. If you are still having problems with this, maybe the next couple examples will help you. So let's keep going. If this is 7 pi over 2, this is 8, 9, 10, 11 pi over 2. Let's see. If I start with 11 pi over 2, another way to get from 3 pi over 2 to 7 pi over 2 is just add 2 pi. So let's see. 3 pi over 2 plus 2 pi. 2 pi is the same as 4 pi over 2. So I just need to add 4 to 3. So 3 pi's plus 4 pi's is 7 pi's. 7 pi's plus 4 pi's will be 11 pi's over 2. If I take that 11 pi over 2 and multiply that by 1/3, I get 11 pi over 6. Oh my goodness, this is also between 0 and 2 pi. Now if I kept going, I know that I'm going to get outside of it. Add 4, I get 15 pi over 2 divided by 3 or multiplied by 1/3. I end up with 5 pi over 2. I know 5 pi over 2 is bigger than 2 pi. 4 pi over 2 is 2 pi. This is plus another pi over 2. So that's out. So notice we have to just be careful. Sometimes we have to look, if we're manipulating to get our solutions for our variable, we might have to look at angles that start out not between 0 and 2 pi. Let's see. Here, cosine 2 theta is equal to 1/2. I'm going to just start by thinking of, okay, when is cosine equal to 1/2? Cosine is equal to 1/2 here and here. That is at the pi over 3, where the adjacent side is 1/2. This is at 5 pi over 3. This is 6 pi over 3, which is 2 pi. Subtract a pi over 3, I get 5 pi over 3. So good. So I know that cosine is equal to 1/2 at pi over 3 and 5 pi over 3. But it's not the cosine of theta, it's the cosine of 2 theta must equal pi over 3 and 5 pi over 3. Now I know, oops. Now I know to solve for theta, I'm going to have to multiply by 1/2. And I know when I multiply by 1/2 these angles, that I'm going to turn this pi over 3 into a pi over 6, making it a smaller angle. This turns into 5 pi over 6, making it a smaller angle. So just because that, I know I'm probably going to have to expand my domain and expand my angles that I'm looking at to start with. So I know pi over 3 and 5 pi over 3. Well, again, if this is 6 pi over 3, not 6 pi over 6, I can add a pi over 3. This is the same as 7 pi over 3. If I have 5 pi over 3, again, you could do the same thing as like what I did earlier. You could add 2 pi to go around the circle. So if I start at pi over 3 and I add 2 pi, I go right around the circle. Adding 2 pi is the same as adding 6 pi over 3 to create a common denominator. So you add 6 pi over 3s to 1 pi over 3, you get 7 pi over 3s. That's how I get there. I can add 6 pi over 3s to 5 pi over 3, and I get 11 pi over 3. So that's another angle. If I went around the circle and then back to this location, it's also 11 pi over 3. I'm going to include those as well. Because when I divide everything by 2 or multiply everything by 1/2, I will get this turns into pi over 6. This turns into 5 pi over 6. I'm just multiplying all of these by 1/2. This turns into 7 pi over 6. This turns into 11 pi over 6. I know I could stop there. 11 pi over 6 is very close to 2 pi. So these would be my solutions. And this is what I want you guys to worry about and concern yourselves with, making sure you understand that you might not start with angles between 0 and 2 pi. You might have to include other angles that are going around the circle so that we can manipulate them to get us answers between 0 and 2 pi. Okay, tangent of 4 theta is equal to -1. 4 theta, that means I'm going to divide all of my answers, all my angles by 4. So I might have to really expand things. Let's see. Give me a second. There we go. Okay. So first I'm thinking about when is tangent -1. Okay, so I'm like almost excluding this and saying when is tangent -1. Okay, so tangent is equal to 1 at the pi over 4. So pi over 4, I have the opposite and adjacent 1. So I'm going to look at the pi over 4 when tangent is negative. That's here and here. So that's going to be at 3 pi over 4 and at 7 pi over 4. 4 pi over 4 minus, 8 pi over 4 minus. Now, know that I'm going to be taking all of these and dividing it by 4 to get my answers for theta. Multiplying by 1/4. Because of that, I'm going to expand the angles that I look at. Because I know this is going to turn into 3 pi over 16. That's going to be like such a smaller angle. And it's definitely in between 0 and 2 pi. This is 7 pi over 16. Definitely still between 0 and 2 pi. So let's keep going. Like I have 3 pi over 4. Let's see the same angle location but around the circle again. So a different angle but ends up in the same location. Add 2 pi. If I add 2 pi, that'd be like adding 8 pi over 4. to get a common denominator. So I'm adding 8, giving me to 11 pi over 4. If I take 11 pi over 4, divided by 4, I get 11 pi over 16. Still well within 0 and 2 pi. This was 7 pi over 4. Again, adding 2 pi to get all the way around circle is like adding 8 pi over 4. So 15 pi over 4 is where I'd be. Still in between 0 and 2 pi when I divide by 4. So let's keep going. 11 plus 8, 19 pi over 4. I'm going around the circle a third time. Divide by 4, still between 0 and 2 pi, this new angle. If I go 15 pi over 4, add another 8 pi over 4, that's 23 pi over 4. Divide by 4, multiply by 1/4, that's 23 pi over 16. Goodness. Let's keep going. Add 8. Hopefully this is outside of it, but let's see. So 27 pi over 4. Also the same as adding 4. So 23, 24, 25, 27, 28, 29, 30, 31. Yep. Yeah, this is a little excessive. Don't expect to see something like this on a quiz. Usually the ones that I'm going to give you, it's going to be, maybe adding 1 or 2, not adding like 17 different angle measurements. So we're still finding that divide this by 4, 27 over 16 is still less than 2. We got to get to 32 over 16. So when I get to 31 pi over 4, divide that by 4, 31 pi over 16. That's really close to 2. I know if I go one more, that it'd get out of there. So just a very excessive example of how we start with finding angles that we think, oh, those are the angles we need, but turns out we might need more. Okay, so don't confine yourselves to between 0 and 2 pi when you have to manipulate things. All right, last one. Seems daunting. If you try to isolate the cosine, it's not going to work out well for you. This actually, to solve this one, the best technique is to factor. And if you factor out a cosine, so you're dividing out a cosine from both of these terms, that's like factoring. If I divide it out of this term, I'm left with 2 cosine theta. If I divide it out of this term, I'm left with a 1. Now, since this is now a product equal to 0, we can use the zero product property, which states that if any piece of a product equals 0, the entire equation will be 0. So that sets up 2 equations, that when this is 0, I'll have solutions for this equation, and when this is 0, I'll have solutions for the equation. Sorry. So when it's cosine 0, I know cosine is 0 at the verticals because I'm not going to the left or to the right at all. I'm just going up and down. When is this 0? Well, I have a different equation that I have to solve. I have to subtract 1, divide by 2. It's when cos theta is equal to -1/2. Cosine is equal to 1/2 at the taller 30, 60, 90 triangle when the adjacent side is 1/2. The taller 30, 60, 90 is at a pi over 3. I need to find the pi over 3 when cosine is negative. Cosine is negative in the second and the third quadrants. So I need the pi over 3 here and here. This is 3 pi over 3. Subtract a pi over 3, 2 pi over 3. Add a pi over 3, 4 pi over 3. And I'm not manipulating any of my answers, so I know definitively these are all of my solutions between 0 and 2 pi. All right, well, this took longer than I expected, but I feel like I need to do it, give you a good resource, so I'm going to keep doing this. I'm going to keep giving you homework videos, and I hope they help. But I'd like some feedback, actually. How did you like this homework video? Was it too fast? Do I need to slow down? Do I need to show a couple examples slower? And then maybe the other ones I could speed up for? Or was this a good pace throughout? Or is it just too slow throughout? So if you are still watching this, please give me feedback when you see me on Monday and Tuesday. Thanks.